The diagram shows particles P and Q of masses m and 0.1 kilograms respectively are attached to the ends of a light inextensible string which passes over a smooth pulley. Q is attached to the particle R of mass 0.5 kilograms by a light inextensible string. The strings are taut and the portions of the string are not in contact with the pulley are vertical. P is in contact with the horizontal surface when the particles are released from rest. The tension of the string QR, which is this one here, is 3.6 newtons. Join the descent of R. Find the acceleration of R during its descent and determine the tension in the string PQ during the descent of R. Okay, so if we first of all just consider the forces on R. So we've got R, we will have its weight acting downwards, which is 0.5 G. We have the tension that we're told this tension was 3.6, and we have an acceleration acting downwards. So if we now resolve vertically, and we're going to take downwards as positive, we're going to have 0.5 G minus 3.6, and it's Newton's second law, so it's going to be mass times acceleration, so it's going to be 0.5 times A. And then we can make A the subject by doing 0.5 G minus 3.6 divided by 0.5, which gives me an acceleration of 2.6 meters per second squared. Right, the second part is we have to find the tension in this string here. So if we just consider the forces acting on this Q, we've got the weight of the mass acting downwards, 0.1 G, and also we've got the tension of this string acting on it. So that's 3.6 newtons given in the question, and we've got the tension that we need to find acting upwards. And we also know it's moving with acceleration of 2.6 meters per second squared. So resolving vertically, again taking downwards as positive, we're going to have 0.1 G plus 3.6 minus t, because it's going in the opposite direction, is mass times acceleration, so it's 0.1 times 2.6 using Newton's second law. From that we can find t. T will be 0.1 G plus 3.6 minus 0.26, 0.1 times 2.6, and that gives me a tension of 4.32 newtons. Okay, so this has been a video to show you how to find the acceleration and the tension in a string in a pulley system. I hope you've understood, and I thank you very much for watching.